Electric vehicles are paving the way for a cleaner, greener future, but ensuring they operate efficiently and safely requires some advanced engineering. One of the most critical aspects of engineering is thermal management engineering. Welcome to our deep dive into thermal management in electric vehicles. In this video, we'll explore the techniques and innovations that keep EVs cool and running. Today, we want to unravel the technology behind the thermal management system in electric vehicles, from batteries to power electronics. Let's see how engineers keep everything cool and running in the optimal temperature. Let's start with the heart of the EV, the battery pack. Batteries generate heat during charging and discharging cycles. If this heat isn't managed properly, it can lead to efficiency losses, reduced performance, and even safety risks. Effective thermal management ensures that the batteries operate in a safe optimal temperature, which is between 20 to 40 degrees Celsius. Going beyond this range is going to shorten the range of the battery pack and efficiency, and it's going to also shorten the battery's lifespan. One common way to manage heat is liquid cooling. This system uses coolant-filled cooling tubes in order to carry and absorb the heat and carry it away from the battery pack. Liquid cooling is highly effective because the liquid has a direct contact with the battery cells, allowing for a uniform thermal management inside the battery pack. And it's also scalable. It's a good and ideal way of thermal managing for the sports EVs and also the commercial vehicles. Another option is the air cooling, which is much simpler and cheaper than liquid cooling, while it is not as efficient as liquid cooling. It is mostly used for smaller EVs because they require much simpler thermal management system. Thermal management isn't always about the battery pack. It also involves the power electronics and the motor controller, which they generate a lot of heat during driving and charging. So an efficient thermal management system is always required for all of these components. Inverters convert the DC power from the battery pack to AC power in order to run the motors. And they're getting quite hot during when they're working. So an efficient thermal management system is needed to cool down these inverters, including heat sinks and in some cases the air cooling methods in order to cool down the inverters inside the EV. Modern EVs are using integrated systems in order to have better thermal management. They have a shared components between the battery pack, power electronics, and the cabin. This is going to allow them to decrease the weight of the vehicle while increasing the efficiency of the cooling. But what happens in the extreme conditions while you're driving in a scorching desert or you're driving in a freezing cold winter? The EVs need to maintain their temperature in all of these conditions. In cold climates, preconditioning is necessary and essential for the EVs. This involves warming up the battery before operation. It is using either the resistive heater or the heat from the motor or the inverter before putting the battery into a high performance activity during a freezing cold weather. Preconditioning is very crucial for the battery pack. Cold is going to reduce the capacity of the cells, and by warming up the battery pack, we can actually regain the capacity and having a more reliable and a higher performance in our EV. Let's not forget the cabin comfort. An efficient thermal management system also balances the passenger comfort with energy consumption. Heat pumps are becoming more popular in EVs. They're requiring much less energy than traditional thermal management systems by transferring the energy from different sections of the vehicle and inside the vehicle in order to warm up or cool down the vehicle. As you can see, thermal management in the electric vehicle system is a critical aspect of a complex design. It involves and balances the efficiency, safety, and performance of the electric vehicle. From liquid cooling to air cooling, integrated systems, and also the heat pumps and preconditioning, EVs can handle whatever the road throws at them. As electric vehicles are continuing their evolving, their thermal management systems also keep running smoothly and getting better day by day. Thank you for joining us on this journey. Don't forget to like, subscribe, and hit the bell icon for more in-depth exploration of electric vehicle technology. Until the next time, drive electric and stay cool.